Yo, what's going on, guys? Have you ever wondered how companies like Netflix recommend the perfect movies and shows just for you? Well, today I'm going to reveal the secret sauce behind these recommendations. By the end of this video, you'll not only understand how it works, but you'll also be able to use this powerful AI technology yourself. We're going to dive into the concept of vector embeddings and how we can use it to compare movie plots to help recommend similar movies for your users to watch. And remember, guys, if you're new to this Next.js vector embeddings, don't worry, I'll break it down step by step, so stay tuned for a complete tutorial of our movie recommendation app. Psst, all of the code is linked in the description to help you out. So where do we actually begin? Well, first off, I'm going to give you a sample database. Now, imagine you have two movies. Each movie has a story or a plot. For example, one might be about a superhero saving the world, and the other could be about a group of friends on a road trip. Now, this information makes sense to us, and we can tell that they're not exactly that similar, but we have to go ahead and translate the plot of the movie into something that the computer can more easily understand, and this is called a vector embedding. So the way we can think of this is we simply turn the plot of the movie into a list of numbers that capture the key elements and themes of the plot. Now, that all sounds well and good, but how do we actually create these vector embeddings? Well, we use something called AI models, often known as neural networks, which have been pre-trained on lots of text data. Now, the guys over at OpenAI have done the hard job of getting this ready for us. When these models are trained, they learn the patterns in the data, how different words can be similar or more far apart from each other, for example. We then go ahead and use this to go ahead and convert something like a plot into a vector embedding, which represents the story. These embeddings have many dimensions, and we can actually specify how many we want to give. It can either be 1, 2, or often hundreds or thousands. Each dimension captures a different aspect of the plot, for example, like the presence of a hero, conflict, or resolution. So if one dimension wasn't enough to capture all the information, you can go ahead and use something like 512 dimensions or even 1,000 plus dimensions, and it will go ahead and further expand the vector embedding to include more detail. Now, once we have these vector embeddings, which represent all of our movie plots, we can then go ahead and do something called a similarity comparison. This is just one of many use cases, but it's the one that's going to be most helpful in allowing our users to get suggestions based on their movies. We can compare the embeddings to see how similar two different plots are. If the numbers are close, the plots are similar. We can also use this in search and recommendation, whereby we can recommend movies to users by finding films with similar embeddings to the ones that they like. Now, here's a fun fact. Streaming services like Netflix actually use vector embeddings to recommend movies and TV shows based on your viewing history. Now, there's so many use cases. You can even use it with things like search engines. So have you ever heard of Google? Well, they actually use vector embeddings to give you your daily search results. You can create vector embeddings with anything, whether it be text or images or any other data format. It works with plenty of different data inputs. So to summarize today's mission, we're going to be converting movie plots into vector embeddings, then comparing how similar they are based on the user's input, and then we're going to return a list of recommended films using the advanced AI techniques that I've spoken about. If this sounds fun, buckle up. The code is in the description. Make sure you smash the thumbs up button if you like this kind of content, and if you enjoy it, enjoy the build. Let's jump straight into it. So here is our beautiful movie recommendation app. You can go ahead and play with it yourself. All the code is in the description in the GitHub repo, but we're going to go ahead and try it out for ourselves. So we simply type in anything that we want. So what type of film do you like? And in this case, I'm going to say space films, and we go ahead and hit enter. And as you can see, super fast and quick. And this is using Next.js caching. So I've already actually searched for space films in the past. So then we go ahead and we get a list of results. Now, I've limited the list of results to 10, but this is the 10 most similar films based on my input. So let's go ahead and try another example. If I was to type in, for example, The Avengers, you can see it goes ahead and gives me the results as these films are inside the database. And the first most similar film is this one here. We've got Avengers Infinity War, the second Avengers Endgame. And then it's going ahead and showing me other films which are similar to the plot of Avengers, right? So in this case, works perfectly. Let's go ahead and actually click into Avengers. So if we click into into it, you can see right now we get all of the information pulled up. But the really interesting part is similar films that we may like. Now, what this is actually doing is it's taking the vector embedding of this film and it's going ahead and running a comparison against the database in real time. So in this case, you can see we get 5 similar films. And if we were to go ahead and, for example, click into Star Wars Episode 6, so if I click on this, you can actually see, look how blazing fast that is, guys. So it goes ahead and gives similar films that we may like, and it even gives a percentage of how similar the film may be. So that way it can give our user a little bit more feedback if they're actually going to like it, or if it's a little bit further apart from the film that we're currently watching. And this is actually what you see typically when you're using something like Netflix or Amazon Prime. So the question is, how do we go ahead and build this? So the first step, I want you to go ahead and head over to the link in the description and go to the GitHub repo. You want to go ahead and either clone the entire repo so you can actually run it yourself, or you can go ahead and click on sample data.csv. Right now, this is all we need. I'm just going to go ahead and download the raw file onto my machine so that way I have access to it. And then we need to prepare our database. So we're actually going to be using something known as Astra DB by DataStax. And this is going to be really, really important for us to go ahead and set up the architecture behind to support everything that we're trying to do. So in the description, you'll find a link to DataStax Astra DB, and you'll land on a page just like this. Now, why DataStax? With DataStax, anyone can quickly build generative AI apps on an unlimited scale on any of the most popular cloud platforms. They support Google Cloud, AWS, and even Azure. DataStax is trusted by hundreds of the world's leading companies such as Audi, Bud Financial, Capital One, and many more to deliver GenAI. But wait a minute, what is generative AI? So essentially, it's a type of AI that is used to generate new content. Unlike traditional AI, which typically analyzes the data to make predictions or decisions, generative AI can produce new data that resembles the data that it was trained on. So let's take a look at some key points to help you understand what generative AI actually is. So in short, generative AI can create new content. It can generate text, images, music, and even more. It can write articles, compose music, create artwork, and it can even simulate human conversations. Point 2, it was trained on data previously. In order to create new content, Gen AI models are trained on large data sets. Typically, OpenAI have been a big player in this space, and these datasets contain examples of the type of content the AI would generate. It then leads me on to point 3, and this is how it works. The AI uses the patterns and structures it learned during training to produce the new content. So if it's trained to generate text, it learns grammar, vocabulary, writing styles, and then it applies all of that knowledge to write new paragraphs or stories. And this takes me back to DataStax. So they've taken the collective experience of their customers that are putting GenAI apps in production, and they created an opinionated stack with the APIs and tools that devs and companies need in order to successfully push their productions out and be production ready. So you can think of it as a one-stop Gen AI stack. Now, when we refer to all of the tools that we might be using, such as LangChain, OpenAI, or Astra DB, we can refer to the entire stack as the RAG stack. Now, Astra DB make our life incredibly easy here. It easily integrates with LangChain, Vercel, OpenAI, and many more, and it's super easy to go ahead and get started. You essentially just follow these simple steps. You install the Astra library, you create or connect to an existing collection in your database, you insert the data that you want to go ahead and input, such as the vector of the data. So for example, if I've put in a bit of text like the movie plot, I convert it to a vector and then I can go ahead and insert it. Or they even have easier ways, which I'm going to show you afterwards, using a special vectorized keyword. And then we can simply go ahead and find the data that we're looking for and run our comparisons accordingly. Now, besides movie recommendation apps, you can also build really cool things such as AI agents. Now, think of AI agents as the level 2 to AI chatbots. AI chatbots have been a game changer for automating responses, but they're restricted by the boundaries they operate in, and they're only limited to the context that we provide them. Think of the AI agents as much more advanced entities. They can understand, learn, and adapt adapt in real time. Leave a comment if you want to see a video on something like an AI agent being built on this channel. And last but not least, guys, they're ultra low latency. So they're built on top of Apache Cassandra. You can use all of your favorite cloud providers. And the best part, you can get started for absolutely free without a credit card. So let's dive straight in. So first step, I'm going to go ahead and hit sign in. Now I've already actually set up an account here, so we can go ahead and sign in with Google. I'm going to log into my personal account, and then you'll see this beautiful dashboard. Now, creating your first database is really easy. All you can go ahead and do is go ahead and click on create a database down here. And we're also going to be setting up our integration. Now, you can get your vector embeddings actually automatically generated for you with Astra DB. So in this case, we can generate from a few different sources. We can do it from OpenAI, Azure OpenAI, or NVIDIA. And in this case, we're going to actually set up one for OpenAI. We're going to first go ahead and create our database. So in this case, I'm going to create a database, and let's just go ahead and call this one test database YouTube. And in this case, with the provider of our choice. So we can go ahead and do AWS, Azure, Google Cloud. In this case, I'm a fan of Google Cloud. Let's go ahead and do that. And we can simply click on the region itself. So I want to go ahead and click on that. And then we can go ahead and click on create database. And as you can see, you've got the option of serverless, vector, or non-vector. We went with the vector database, as of course, we're going to be storing vector information inside of here. Now, that will go ahead and prepare our database. Now, while that's happening, I'm going to take you over to the integration section on the left. I've already connected my OpenAI connection. However, all you would have to do is click on OpenAI, and then down here, you simply have to go ahead and add in an API key. Now, to get this API key, it's super simple. Simply head over to platform.openai.com/API-keys. Then you want to click on create new secret key. And in this case, if we were to go ahead and create a key, I'm going to say my test key. And then you can go ahead and click a default account, set your restrictions, and you can create your key. Now, I've already done this step, and as you can see, I've got a secret key over here. So you want to go ahead and make sure you copy the secret key that is put on the screen. Then you want to head over here. Once you've got your key, you want to go ahead and provide a test key name here. So in this case, I can just call this one test key. You want to paste the value here. So this will be something like the following. So you want to go ahead and paste that key in. And then you need to provide the databases that you want this integration to work with. So I've just gone ahead and added the test DB YouTube. So I want to go ahead and do that. And you can go ahead and actually select up to 10 vector bases to add to the key scope. But I'm going to go ahead and click on add integration. Now I've already done this step, so I'm actually not going to click that. And you can see I've already got my connected database set up like follows, right? So in this case, I'm simply going to go ahead and modify my existing database to add in the new database that we just created. So as you can see now, I've got the new database added to the API key. So heading back over to the database, it's now ready. You can see we've got a nice, clean, empty vector database. You've got lots of different options here. You've got a nice little bit of documentation, and you've got a very clean connection library, which shows you your first steps to actually connecting to the database, which is awesome. But we're going to go back to this in just a sec. The first step is we want to actually load our sample data. So I want you to actually click on load data here. And I want you to actually go ahead and you can use the sample collection that they give you, or we can actually go ahead and create an empty collection ourselves. We're going to call this one movies. It is a vector enabled collection. And that, as we've connected our integration, you should see OpenAI. So OpenAI perfect. You then will have a drop down for your key. In this case, my key is here. The embedding model is the next important step. Now, Ada 002 is the oldest model. However, two new models have come out, text embedding 3 small and 3 large. In this case, we're going to use 3 large as it's a very cost-effective method. And then you can select your dimensions. We talked about dimensions before. Ideally, we want to have a higher number of dimensions. However, obviously, with a higher number of dimensions, it can get more computationally expensive. So in this case, we're just going to go with 512. And then we have this similarity metric over here. Now, there's lots of different similarity metrics that we can actually go ahead and use. Now, one which is very popular when we're comparing text against each other is cosine. So we're going to go ahead with cosine, and then we're going to click on create collection. Once this is done, we need to take that sample database that we got from our GitHub repo, this sample database, and we're simply going to go ahead and drag and drop it into our collection once it's ready. We're going to click on the load data. So you can see now it just popped up. We're going to go ahead and click on load data, and I'm just going to drag and drop that sample database that we downloaded earlier. I'm just going to go ahead and drag and drop it onto here. And then we should be able to preview all of the data. So here you can see we've got a list of, I don't know, I think it's about 200 films or so. And basically now we have to determine which field is going to be used for the vector field, right? So which one are we going to basically pull all of the information, which essentially tells us what this film is about. And essentially it makes more sense to be using the plot than anything else here, right? So in this case, we click the drop down and we select plot. Now, remember what we spoke about. It will take the plot of each film and it will generate a vector embedding from that. And it will be using the OpenAI model to do so. So here you can see just by setting up a simple integration, as you can see here, now all we have to do is tell it which field to go ahead and vectorize, and then Astra DB does the rest of the hard work for us. So we simply click on create dataset, and then you can see it will go ahead and load in. Now give this a minute. It will take a little bit of time just to go ahead and get set up. But in the meantime, let's go ahead and get our connection details so we can get our app up and ready. So if you head over to connection details, hit TypeScript client, as we're going to be using TypeScript, it shows us the steps to get started. We have to install the npm dependency into our Next.js project. And then we can go ahead and use this small little snippet to make a connection to the database. And if you see here, we have a special token that we need to go ahead and get set up to get this up and running. And to get that token, we simply click on generate token here, and it's a secret key, so you do not want to go ahead and show this. You want to copy that, and then we can use that inside of our build. So boom, there you have it. We have 250 records and we have 512 dimensions with the model of our choice. And as you can see, we have all of the information that we actually need inside of our database, just like we needed. So looking over here, all of the fields are preserved. So it's just a normal database, except now we have this vectorized plot. Now just means that essentially it was mapped to vectorize upon the import. So we still have that information. However, as a little side effect of the embedding, we now have this new vector. And this is the really cool part. So we did 512 different data points. So if I was to go ahead and simply paste that just here, you can see there are 512 different entries over inside this array. And that is essentially is representing the film in a way that the computer can understand. So each different entry you can see here looks like the following. Okay, so now we can basically pull this and we can use our app accordingly to go ahead and get it doing what we need to do. And you can also play around with this right here. So to actually, before we even get started with it, if I was to, for example, click on Terminator 2 and I do a vector search, essentially I'm telling it to find all of the films that are similar to Terminator. And you can see, obviously, Terminator itself gets a 1 score, which means it's a 100% match. And then the Terminator, which is the first film, has an 84% match, followed by Blade Runner, Jurassic Park, Dune, and so forth. So this is how the similarity check will work. And what's another cool thing is that you can actually test out what we're going to be doing here as well. So you can see sci-fi movies with ratings above 8 and so forth. In this case, let's just type in something like superhero movie and hit on apply. And as you can see, we should see The Incredibles, Spider-Man, Logan, V for Vendetta, Joker, and all sorts, right? So these are all essentially superhero movies. The goal now is to go ahead and get this information into our app. But just like that, guys, it was that easy to go ahead and create the vector embeddings required to start comparing different films. And if you really just kind of zoom out and think about that for a second, that is incredibly powerful. We've already got, after a few moments of simple setup, we've already got vector embeddings, so we can go ahead and compare different film plots against each other. And it was that simple to do for free. Okay, so the next step is we're going to go over to our GitHub repo and we're going to clone the repo. So let's go ahead and do that right now. Pull open your terminal. And you simply want to go ahead and pop it inside the following. So in this case, I like to go ahead and put my apps inside of a nice folder. I don't recommend that you just stick it anywhere. So in this case, I'm just going to go ahead and pop it inside of my build folder. So you want to go ahead and type in git clone and paste in the repo. This is a public repo, so you should have no problem in doing that. Then we're going to cd into the movie recommendation folder, and then we're going to go ahead and type in code dot. If it doesn't work for you, you just simply have to go ahead and install the shell command by hitting Command-Shift-P and type in install. Now I'm using code insiders, so it'll be code-insiders for me, but I've just aliased it to code. However, for you, if you're just using VS Code itself, you won't have an issue. Install that, and then you should be good to go with the following command. Now here you can see we've got a Next.js app. It's all been set up for you. And the reason why I've given you the code in this way is that you will be able to go ahead and just break it down yourself and see. But I'm going to go ahead and run you through the entire setup so we can get our app up and running. Inside of environment example, this is where we need to first start off. So first off, we have the application token. Now the application token, if you remember inside of DataStax, if we go to our connection details, we generate a token. This is the token that we're actually looking for. So first things first, you might notice this is an env example file, which means it's not actually being used. We need to create a new file called env local, and this will be the one that will pull in the variables. And all you want to do is copy the example files, pop it inside of there, and then we can go ahead and copy our token that we just generated and pop it in like so. The next step is the API endpoint. You can see here, we've actually got the API endpoint given to us really nicely in the documentation. So you can go ahead and paste that in. And the final step is getting your secret key. Now I've got my secret key right here. And if you guys do try and access any of these, it's not going to work. I've actually deactivated these keys by the time that the recording has come out, but it's just so it makes it easier for you to understand. So in this case, we've got our 3 environment variables perfectly set up. And we can actually go ahead and actually run this app, and then I will run you through the code and show you how it works. But first off, whenever you git clone any repo, we need to install the dependencies inside of package.json. So we're going to type in npm I to actually install all of our dependencies inside of our app. So there you go. Now you'll notice that all of the errors that were previously showing are actually gone as well. And then we can run our app by simply typing npm run dev. Let's see this. If we go over to db.ts, we can actually get an insight as to how it will firstly start. So you can see the database is initialized. We basically check if we have those environment variables previously. If we don't, we'll throw an error. Then we initialize it with the token, and we go ahead and create a fetch request over to our API. And then we create a instance of our DB by connecting to the API endpoint. Okay. So in this case, we have our client with the correct authorization, and then we connect to the API endpoint. And you can unconsole log this out if you want to see the connection happening each time. Okay. So now we've done that. Let's go ahead and look at our app and see if it's actually working. We should see the full app in its full glory. There you go. There we go, guys. It's working perfectly right now. Let's go ahead and see and deep dive into the code itself. It's fairly straightforward to understand, pretty simple app. So if we were to type in superhero films, hit enter, we should be able to see like the Avengers, Logan, and so forth. So this is great. If we click on the Incredibles, we can see we've got our 3rd page, which is the movie page. And here you can see you've got the similar films. Now, how does any of this work? And if you want to go home, you can simply click on that, right? Let's dive into a bit of the code and get a better insight as to what's going on. So first off, if we look at page.tsx, this is the home page. Now, as you can see here, I'm just going to make the code a little bit bigger. As you can see, firstly, we've just got a nice little bit of caching. So every 24 hours, the page will refresh its cache. So that way, every user gets a really fast load time. But here's the important part. So I'm not going to dive too much into how server components work, but we can go ahead and dive into the main gist of it. Well, firstly, this is what's output on the screen. So we can ignore that for just a second. Let's look at what happens before we see any output. The first step is we create a connection to the collection movies. Now, looking at our Astra DB, if we were to go over to our databases, and let's go ahead and head over to our TestDB YouTube. The first collection that we're interested in, if we go to the Data Explorer, is the movies collection. So you can see we've got the movies collection over here. So we're going ahead and we're essentially connecting to our movies collection. So I'm going to go ahead and just draw this on the screen right now. So first step is we're going to create a connection to our movies collection over here, right? So in this case, I've actually called it messages here. I was trying something else out before. Let's just rename that to movies and hit save, and I'll update that in the code. And then what we do is we basically want to fetch all of the movies themselves, right? So in this case, what we do is we simply create a await call, and we do await movies dot find, and the first argument is actually any kind of filter. So if I was to go ahead and pop open this again, you'll see the first argument is a filter. And that's where we can go ahead and we can do sort, limit, skip, and we can also filter based on different things such as the individual metadata inside of a file. However, in this case, we don't really need any filtering to happen on the home page. The second argument is where we can pass in the options. So we can limit it to like 10 results. We can choose to include the projection. The projection means that if you want all of the data, however, without the vector information, you can uncomment this line and do that, for example. And then what we do is we do the toArray function, okay? And I'm simply casting it to the movie type. And I've gone ahead and made life easier by creating a movie type. So this is simply TypeScript definitions. So that way you can access each thing a bit more simple. Then we have some simple Tailwind styling here to go ahead and list out the items on the screen. And then we map through each of the movies using the movie poster component that we've built. This is very simple. It simply takes the movie and it basically populates it onto the screen with the nice little bit of styling attached to it. The main thing to consider here is that each movie poster is clickable and it takes us to the /movie/movie ID, right? So we're going to dive into that in just a second, but let's just see that in all of its glory, right? So let's see the home page. And right now you can see I'm on the home page and that is exactly how it was working, right? So we simply made a fetch to all movies and that will give us all of the items in the database, right? So you can go ahead and obviously implement lazy loading, that kind of stuff if you want to. However, that for now will do the trick perfectly. Now, this search field. So the first thing, if we go to our search input is based inside of a layout, which is based inside of the header. And then you can see I've put the search input here. And all this is really doing is we're using server actions under the hood here, is we're essentially create a form and you can see the form is here. And when I type in the form, all I'm doing is essentially doing a server action. And this is an inline server action, just for example's sakes. We take the search term that you typed in and we redirect you to /search/your term. And this actually keeps the entire component a server component, which is quite nice. And it prevents the re-rendering of your component. So it keeps the whole Next.js flow intact. And then the real magic happens on the /search screen. So we've seen how the home page works. We're going to next jump into the search screen, and then we're going to jump into the individual movie screen. So first up, search screen. Let's type in space films. And if we head over here, we can see we get some results. And we've actually limited to 10. So let's take a look at that itself, the code itself. So we go over to our app and we go to search and we've got the term, which is a wildcard, and the page.tsx. So inside of the search page itself, we can actually see we get the term from the URL. So in this case, you can see it's space films. We pull that from the URL. We then create a connection to our collection movies, and then we go ahead and get all of the similar movies. Now, the way we do this is we actually vectorize the term. And you might be wondering, well, Sunny, don't you have to pass in a vector embedding, which looks something like this? So 0.234 or whatever it was, right? So these are just a bunch of different numbers. So let's just imagine that this was a vector embedding with dimension of 3. Wouldn't you have to pass this in? How are you passing a normal term in, like space films? Well, in fact, over at Astra DB, they have this really handy vectorized keyword. Now, if you simply pass in the vectorized keyword, you can pass in any text string and it will automatically use the OpenAI integration or whatever integration you've set up to create a vector embedding of that. And what I've done for simplicity's sake is in the page.tsx homepage, I've shown you how, if you need to create your own embedding, how you can do just that by using a fetch call such as this. So essentially, it's just doing this under the hood for you. Okay, so we can go ahead and call the vectorized term. If you ever do want to provide a vector yourself, you can simply pass the vector in, and that's where you would pass it in, right? Like so. So in this case, we're simply passing in the text term. Then we limit the results to 10, and we don't want to include the vectors in the output, right? So I'm trying to simplify things. Then we do the toArray and we cast it to movies. And then the following down here, again, just rendering out the movie poster itself. So that is the search page. And then, like we said, very simple, reusable components, works perfectly just the way we expect it. Now, if I was to click into, for example, Interstellar, this is the final page where the magic happens. So this is actually the movie page. And most interestingly here is the similar films that you may like. So in this section right here, we actually provide Interstellar's vector to the database to go ahead and get the most similar films. And if you remember, we actually did an example of this earlier. So if we look in the database here, and for example, I went over to Spider-Man, and imagine I landed on Spider-Man's page, I'm essentially simulating a search with this vector. So you'll notice that that vector went into the search, it applied, and now it found all of the similar films that are going ahead and showcasing. So we're going to basically crop the first 6, in fact, and leave the first one out. And then we're going to go ahead and show that on the screen. Okay, so let's go back over to our code and see how this just works. So heading over to our movie page.tsx, we can see we get the ID from the URL, we connect to the movies collection, and then we do a filter find, right? So in this case, we do movies.find, and the first argument, as I showed you previously, is actually the filter section. So in this case, if I was to go ahead and do a bracket, you can see the first argument is a filter, and the second being the options that I've shown you previously. So here we're saying find all of the films and make sure that this constraint is met, right? So in this case, where the ID matches the ID of the film that we've gone ahead and passed. And you'll notice that when we're on that page, if we have movie / the ID of the movie. Okay, so you can obviously structure up your app the way you feel or the way you need to. We simply have a protective statement to make sure that if it's not found, we render a 404. And then we go ahead and do search.next. And this just simply gives me the document itself, right? Now, the interesting magical part here is getting the films based on that film itself. So what we do is we do similar movies, and then we do an await call, movies.find. We're not filtering here, but instead, I'm showing you how we're actually passing the movie that the page that we're on, that movie. So in this instance, Interstellar, we're passing the vector of that movie. And you'll notice how I wasn't excluding the vectors here. So it actually returned in the results. We're passing the movie of that vector as a vector argument. And then we're limiting to 6 results. And the reason why we do 6 is because the first movie is actually the same movie that we pass in. So we're going to crop that one out by using shift, and then we're going to go ahead and do the following. So in this case, use similarity as well. You can go ahead and mess around with a couple of the options. I won't go too far into it. And then we convert it to an array. And I've gone ahead and created another data type here called similar movie, which actually just has one more additional component, and it extends movie. And this is a similarity, which is how we determine what percentage is returned, right? So when we actually do a include similarity call here, it includes how similar the result was. So if you remember in the example here, the similarity score, that's all we're doing by having the include similarity attribute here, okay? So next step, we similar movies.shift. So we cut the first movie out because it's the same as the film. We don't want to show, Interstellar again. So in this case, we don't want to show Interstellar and then similar films Interstellar, right? It doesn't make sense. So we cut that one out, and then we've got the other 5 films which are closest in our database of a match. Then we simply render it out with a bit of style, Tailwind CSS, and the movie posters themselves. So just like that, guys, we've gone ahead and created a movie suggestions app fully powered by generative AI using Astra DB. We've created our own vector embeddings from our database. And remember, you can do this with any form of data. It could be images, it could be text. And then we've actually gone ahead and generated our own vector embeddings, and we use that inside of our app to have this suggestions field right here, right? Now think about how far you can take this, guys. You can really take this to the point of, making personalized recommendations based on what each user is liking, and then create vector embeddings from that and compare those when the user goes ahead and selects their next film. And you can really take this as far as you want. If you're interested in me making more videos on this topic, then let me know down in the comments below. I'm more than happy to dive deeper into the AI rabbit hole, which is going to broaden your experience and go ahead and make you more attractive to your future employers. There we have it, guys, a movie recommendations app built in record-breaking time. All of the code is available in the description down below, as well as a special link to go ahead and get started with DataStax and Astra DB today. So make sure you go ahead and click through that link, as it helps support the channel. Now, if you enjoyed this video, don't forget to subscribe to the channel and smash that like button so that this video gets pushed out to as many developers as possible. And if any of this is really confusing and you want to go ahead and make sure that you nail it and master it, we cover all of this inside of our flagship course, Zero to Full Stack Hero. The link is also in the description, or you can simply head over to www.papareact.com/course. As always, guys, it's your boy Papa React, and I will see you in the next video. Peace.